All right, good afternoon. This is Erin O'Donnell. I'm the program coordinator at America Makes, and we are joined by John Wazinski, the technology director at America Makes. We are hosting our second kickoff of the day. It will be the Advancing AM Post-Processing Techniques, or AAPT, for this most recent project call. A few important points to note. We have the kickoff scheduled for an hour. It may not take the entire time, but we will be available. The kickoff is being recorded and will be available along with the kickoff slides on the Project Call website under Available Resources. Make sure you go to the AAPT website and not the AllSAM website for this kickoff. You will notice the kickoff presentation aligned to the RFP. And due to recording of the kickoff, we have all the mics muted. So please type all of your questions in the Q&A box in the bottom right-hand side of the window, and we will address them. We will attempt to answer all of the questions. If we run out of time, we will post the answers to the website Friday afternoon. And they will be posted underneath the AAPT project call. If you had called into the AllSAM project call kickoff, you will notice it has the same method. So you will be hearing some repeats and some new information. So to kick this off, we will be going through our project call summary. As I mentioned, it aligns very similar to the RFP, so we will be taking out important points and making note of those, but all of this information will also be available in the RFP. An important note, especially for this project call, if you are also doing the AllSAM, is that this one is a two-step process, whereas the AllSAM is a one-step. So the concept paper is required for this project call. Moving right into the schedule, a few important points. We have the questions from proposers about the scope and approach are due August 8th. So please send those to projectcall@americamakes.us by the 8th. We will respond to all of those questions simultaneously, and they'll be posted on the website on August 13th. If you are participating in the project call and have proprietary information, an NDA needs to be done by August 10th. The concept paper submissions are due August 24th by 5 p.m. Eastern Daylight Time. If you are selected to do a full proposal, you need to be an America Makes member by September 28th if you are the lead proposer. Project team members are not required to be members, but it is encouraged. And finally, if selected to submit a full proposal, the full proposal submission due date is October 12th at 5 p.m. Eastern Daylight Time as well. I'm going to now kick it off to J-Dub, who will provide information on the background and objective, as well as connecting it to the DoD, connecting this project call to the DoD roadmap. So John, take it over.
All right, thank you, Erin. So I'm going to talk through a little bit of the background and kind of overall objective that we're looking to address through this project call and the specific topic of advancing AM post-processing techniques. So we're all quite aware of, how essential additive manufacturing is and the opportunity, specifically tied to ability to create, unique, complex geometries, interesting internal geometries that aren't currently or aren't really possible through other manufacturing technologies. But we also realize that the surface quality or surface finish that is produced through most or all AM processes are not adequate for or not acceptable for much of the application space that we're looking to utilize them for, or at least we could call it out as a specific manufacturing risk for a variety of the different components that we would like to utilize the technology on. There's a much uncertainty that exists around it. So, and we know that, or at least have a strong feeling that a large portion of the risk associated with this is derived from different pre- and post-processing techniques and, kind of approaches. So that includes everything from how, what are the best practices for handling the material that we're utilizing in the process, what are the various post-processing techniques and technologies that we, that need to be utilized after you build the actual component using the additive manufacturing technology, and what impact do those post-processing things like hot isostatic pressing actually having on the part. So all of that rolled up together is, has created quite a bit of uncertainty, and there's folks out there that do portions of this very well. And there's definitely instances where organizations have gone through the steps to document these different processes very well and have some, data that they understand at least on a part-by-part basis the implications and impact that it has. But overall, there's still significant qualification challenges that exist around here. And if you think of it from, government point of view and Air Force and where they're at and trying to get to the point of qualifying components for aircraft, uncertainty in this space is, leads us to a point of, it's really a non-starter if we don't understand what those different challenges really lead to. So some of the examples of challenges that we're looking to address specifically on this project are, what does cross-contamination of material feedstocks really mean? How do you control that? What are best practices around that? AM-specific corrosion, we're interested, here in a second, the objectives of, use of as-built surfaces, so better understanding what it means to not have to post-process a surface after it is additively manufactured. What implications does that have on the actual part quality coming out of the machine? What are the circumstances and effects of utilizing hot isostatic pressing? What are the effects of starts and stops and shadowing and things of that nature? So we understand kind of overall this background space. There's quite a bit of uncertainty, and that is uncertainty associated with the pre and post-processing side of things. So what we're looking specifically through this project to address are these two objectives that are called out on this slide. First being, or I guess one being, to quantify the mechanical performance of SLM surfaces on, and there's some specific requirements we'll hit on again, but high temperature nickel alloys, and looking at some conical features, so things like thin walls, narrow flow channels, things of that nature. So what impact, or what is the debit if you're looking at it from a design curve point of view? So we're looking for teams to capture and document design curves on as-built mechanical property debits for coming out of the additive system, and what implication does that ultimately have on final part quality, and thinking specifically of interaction of surface quality, so rough finish coming out of the system, surface connected flaws, and kind of moving into the next objective here, or the other objective rather, is quantifying the effectiveness of HIP. So I'm sure many of you are very aware that there's lots of thoughts in this area of HIP, but specifically what we're looking to address here, and the objective is to quantify effectiveness of HIP this is again on nickel alloys, same conical features or same types of conical features for thin walls and narrow flow channels. So what effect is HIP really having on final part quality, as it comes out of the post-process. You know, when should it be used and when shouldn't be used? What effect is it really having based on, you know, different scenarios of, or based on different features that you would expect to utilize this on when you're thinking of complex geometries and, you know, areas where additive, you know, is really plays a major advantage. So a key point here is that last sentence on this page. Proposers may consider addressing both issues above and their potential interactions. So it is not required to address both HIP and surface quality, but as suggested by the last sentence there, we're definitely interested in looking at and evaluating proposals that do address both. So it's really up to you as a proposal team to identify the challenge space, you know, document that well enough, and determine how much based on some of the, you know, funding that we'll talk about in the end, you know, what you can really get done in the period of performance and for the dollars that are available for this effort. So next slide, Aaron, is how this is connected to the DoD roadmap. So this, like most everything we're working on now at America Makes, has direct connection back to the America Makes roadmap, and in particular, in this case, the DoD roadmap. So a couple of years ago, we worked with each of the services individually as well as the DLA to put together service-specific as well as an integrated additive manufacturing roadmap. The Dod Integrated Roadmap has been well publicized. I'm sure all of you have seen it. If you haven't, it is available on our americamakes.us website, and there's actually a reference, I believe, within the RFP that you can get to it directly through the RFP. But there is direct connection back to topics that were identified by that defense community. And ultimately, you know, what we're seeing here is a need that's been identified. The voice has been, you know, repeatedly identified from, you know, various services, from industry. Everyone is very interested in this particular space. We funded some work that is kind of associated with this. Actually, a little bit of the work that's gone on in the most recent MAMOS Phase 3 project call is somewhat related to this effort. But in particular, we're tying the ask for this current AAPT project call back to these two major DoD roadmap elements, one being establish stable and robust AM processes. And really what we're looking to do here is really understand, you know, what the effects of as-built surface quality is, as well as what the effects or what the part quality post-heat treatment through hot isostatic press really yields in as far as part quality goes. So expectation is the teams put together a plan to kind of quantify that and make those results available. So put together a test plan that kind of walks it through all of the appropriate paces and then documents it and makes it available to membership. The second major area for alignment to the DoD roadmap is that of develop qualification and certification methods for parts and systems. So as you're all very aware, there is a need in a very loud voice across all services and industry right now to, you know, better understand the qualification and certification space. How do we get to the point of being able to more rapidly qualify part families and things of that nature? A step towards that is understanding these associated pre- and post-processing effects. So, you know, the specific objectives that we've called out are around, you know, again, surface quality or surface finish rather, and what that means to the as-built surface and the eventual or ultimate part quality, as well as the effect of hipping a component. So there's nice connection back to the requirements and needs that have been stated by the DoD, and it's something that we continue to hear, and ultimately it was how we were able to pull the topics together. If you go to the next slide, you'll see the specific project requirements. So here you'll see where a material that we're looking to focus on is nickel alloys, specifically called out 625, 718, and 230. So we're looking for teams to propose research that is specifically aligned to parts that are demonstrated through these particular alloys. From a machine requirement point of view, it has to be produced on a SLM system, and build volume needs to be at a minimum 8 by 8 by 10 and utilizing at least a 200-watt laser. So just, kind of the parameters we need to make sure you're operating in. It can't be a system that falls outside of those parameters. Melt parameters, use of industry accepted parameters and heat treatments are strongly encouraged, meaning we're looking for teams to propose back, and then ultimately, if selected, the teams that are selected to execute heat treatment strategies that are based on accepted industry standards, so things that are being done today. So, think about that as you're building your team out so that you have appropriate representation, whether, it's not suggesting that there's any particular role that that industry member needs to have, but you need to make sure that you're, ultimately doing something that is transitionable and impactful for industry and utilizing strategies that they're currently using. Properties point of view, we're looking for both static and dynamic mechanical properties and microstructure. And this last item here, transition. So we want the team to consider or propose how to demonstrate a path to adoption with SDO. So we've done a lot of work in the last 2 years with ANSI to develop the AMSC, different versions of the roadmap. But through that, we've had a lot of engagement, and I'm sure many of you have been engaged in that as well, work with the different standards development organizations. So how do we take the work that you're going to be executing through this program and make sure that we're able to demonstrate a path toward adoption, or really kind of how do we transition that information to an SDO that it can ultimately get realized in, standards or specifications that are more broadly impactful. So meaning can be viewed and utilized by all. The next slide, I believe, just really hits on a couple, highlights things from, the last couple slides. So SLM process only. So that's the only systems that we're looking for you to propose against. Again, nickel alloys as represented here, 625, 718, and 230. Looking for these are the two major objectives: effectiveness of HIP on conical features, thin walls, narrow channels, unimproved surfaces, and then second here, establishment of property debits for as-built surface quality on the same kinds of conical features. And then finally is that kind of the transition piece. How do we make sure that it gets connected and is broadly, visible and utilized post the project being completed? That's it from me, Aaron.
Thanks, J-Dub. I'm going to head over to the funding overview. So there is a subcontract total of $1.6 million available. We are expecting at least 2 awards, at least up to the amount of $800K. It can be less should a proposing team come up with an idea or process that doesn't require the $800K per project. Please note that the cost share match is 50% minimum, and the total with up to 2 awards being project awarded will be $2,450,000. The period of performance is going to be 24 months or 2 years, with 3 months tagged on to the end for technical writing and final reports. An important piece to note is I've included the incremental funding projection. The reason being is when the teams are submitting their full proposal, we would like them to consider the funding per year when they are building out their cost and budget to be proposed. So there's an important point in this that I want to note. Since this is a 2-step project call, the concept paper does not require the funding be submitted. That will be, if teams are selected, they will submit that at the full proposal stage. Next, we have the deliverables. So the deliverables are similar to majority of American Makes projects. You have your monthly reporting that includes financial and technical. We also include the cost share, the final report, which will be for the last 3 months of the project period of performance, the data management plan that will be created out of the information and or determines how we are going to create the project at the project inception. And then something that doesn't normally happen is a data management review. It is required 6 months after project award and 6 months prior to the POP end. So you'll meet with NCDMM and AFRL personnel and go over that information. And then the technical data that is gained during the project call during the project will also be considered deliverable and released to the American Makes members. So, project call summary. So I'm going to reiterate this. Multiple awards, at least 2 projects, and a 2-step process. Important dates that I want everyone to consider are concept tool, the white paper. You have approximately 30 days, and the submission is due Friday, August 24th, before 5 p.m. Eastern Daylight Time. We are anticipating the teams that are selected to write a full proposal are to be notified on Monday, September 10th, and the full proposals also have a 30-day proposal time, so submissions are due Friday, October 12th by 5 p.m. Eastern Daylight Time. So concept papers, Friday, August 24th, selection notice Monday, September 10th, full proposal due Friday, October 12th. For the project call evaluation criteria, step 1, the concept papers will be evaluated using the technical approach and methodology. That is the majority of the evaluation, so make sure we take some time and put a lot of thought into that aspect, because that goes up to 60%. And the next is the technology transition, so whether it be to American Makes members, the Air Force, or the SDOs. If selected to complete a full proposal, the evaluation criteria is very similar to previous project calls. The executive summary is up to 5%, technical approach and methodology heavily weighted up to 50%, technology dissemination to American Makes members in U.S. Air Force 30%, and program management approach is 15%. That program management approach is how the lead runs their project, including their subcontractors, stays on schedule, and cost. Finally, similar to previous project call exhibits are included in the RFP. They are included in a Word format so that they can easily be copied over and inserted into the proposal submissions. Exhibits are only required if selected for a full proposal. We also want to make sure that everyone takes a good look at Exhibit 5. This is the identification of consortium-developed IP and deliverable artifacts. So team members make sure to pull out previous or background IP and submit it with that full proposal. Reporting. Reporting is similar to all of the American Makes projects. There's monthly status reports, whether it be technical, financial, and cost share. Team members are expected to attend at least 2 times a year, an MMX or a TRX, or provide a webinar. The data management review, as mentioned in earlier slides, 6 months after inception, 6 months prior to the period of performance end, we'll meet with the NCDMM and AFRL staff. You'll have virtual team meetings, and it's expected to have a kickoff meeting with the NCDMM, PM, and AFRL within 30 days of the contract award, as well as delivery of your consortium-developed IP and Exhibit 5, and then the final report. As mentioned in the schedule, we have opened a question and answers period. That is from the August 8th before 5 p.m. Eastern Daylight Time. All responses to the questions will be submitted and posted on the AAPT webpage. They will be posted on August 13th. There will be no individual questions answered, or no questions answered individually, I should say. There is a frequently asked questions document out underneath the AAPT website. Please review that prior to submitting your questions. Most of the time, the questions that are submitted can be answered within the project call's frequently asked questions. Again, all questions should be emailed to projectcall@americanmakes.us. And as I mentioned, responses will be posted simultaneously on August 13th. And an important note, questions directed to NCDMM personnel and not to the project call at americanmakes.us will not be considered. So if you want your question answered, please make sure you send it to the project call at americanmakes.us. And now we're going to lead into questions.
Great. So I have a handful of questions that have come in, so we'll go through and provide responses now. Mark Benedict from AFRL is also on the line, so I'll rely on him for parts of this. If there are things, which I think there are based on reading them already, that we're going to have to kind of go offline and get documented, we'll get those collected, and we'll collect our answers as delivered today and make sure they're available for everyone to see. So the first question, and so please start pumping questions through if you have some, or if any of these questions spark something in your mind you want to have clarified. First question that came in is, can you say whether the targeted application is heat exchangers? The canonical features of interest point to this conclusion. So Mark, I'll open it up to you, but I believe the answer is no, it's not specifically heat exchangers. If that's how you choose to build your proposal around it, that is okay, but I don't think we specifically are only looking for heat exchanger applications.
Exchangers, but those are certain. I don't think it's limited to heat exchangers, but I certainly think those are one of the application areas of interest. So, showing an understanding of the performance limits of the features in question in that application would demonstrate, some understanding of the problem space, I think. But again, it's not solely limited to that.
Perfect. Next question is, can you elaborate on mechanical properties desired? Specifically, can you elaborate on the mechanical properties desired? Are you looking temperature, strain rate effects, low cycle, high cycle fatigue? Is there something in particular that we're looking for here, or all of the above?
So I think it's strength properties at temperature, low cycle, high cycle fatigue. Those, the ones that are typically used as screening properties, really to identify mechanical trends and identify the efficiency of the hip versus no hip, or again, the challenges with as-built, accepting as-built surfaces.
You.
I think one clarification there. I think that it probably would not be seen as a positive if you were just to focus solely on strength, as an example. You know, a range of properties perhaps is the best approach while keeping within the scope of the funding and time allowed.
Great. Next up is, are you interested in the effects of surface smoothing on fatigue?
No, I think the intention of this is to understand the limits of the as-built surface. Now, if a proposal was to say that, you know, to demonstrate those effects, we have to perform surface smoothing, then, you know, I think that would be seen as certainly allowable, but we don't want to consume a large amount of the resources in this project with, you know, a survey of different surface smoothing techniques and how they would interact with the features that we've highlighted.
The next two, I'll ask them individually, but I think they go together pretty neatly. Can you define conical features a little better? And the kind of accompanying question, I think, is how thin is thin? How narrow is narrow? Are we interested in the limits of thin walls and narrow channels that can be fabricated? Or are we interested in addressing RFP issues for larger, easier to fabricate features? So do we have any definition on what exactly we're looking for?
So the canonical features, the standard features that we're interested in, again, are thin walls, relatively tight radii, passages of you know, fairly narrow dimensions that could, you know, have some pressure requirements or flow requirements. Whether we're pushing the absolute boundary, you know, I don't think it's appropriate necessarily to push the absolute boundaries of fabrication, but, you know, what is in experience we've had, you know, 10 mil wall thicknesses are certainly achievable with the materials in question. And, you know, I would suggest that scaling up from there would be appropriate till you get to a point where, you know, you're effectively in a bulk condition or feel you are.
Great. Are there any specific or high priority applications under consideration for the features?
Could you repeat that? Audio broke up for me.
Sorry. Are there any specific or high priority applications under consideration for the conical features?
I mean, I think it's yeah, the application of the features themselves are typically, you know, whatever a thin wall would do in normal operation, whether that's lightweighting or, you know, heat transfer or pressure retention, or, you know, potentially all three. The passages that, you know, were mentioned are typically heat transfer and fluid flow type applications. So those are the functions of the features. The function of, you know, I think that's all we have to go into there.
Next up is, does a research group need to have their own nickel alloy capable AM equipment? So
no, not at all. You know, it's evaluation of the process as it exists. You know, we're not calling for this project call certainly is not calling for process development. We're not asking you to optimize parameters or, you know, advanced materials that don't exist into the additive space. And perhaps that's working with a partner to actually fabricate samples. So I think that's entirely allowable. At the end of the day, we just have to have, you know, I think that as part of the data management discussion, very strong pedigree on the material generated. So we have confidence in the conclusions that result from testing of the said material.
Great. Next question is, do you envision concepts or proposals addressing all three nickel materials or a single selected material?
You know, I think that either solution is possible. My caution would be that three could be a challenge in terms of scope. It depends on the range of properties that you choose to address. Again, I did highlight that focusing on a single property is unlikely to provide sufficient confidence to do trending towards other properties. So there are some properties that, you know, are just not, you know, porosity doesn't affect strength until it gets pretty prevalent or gross. So if you solely scan that property, you would probably tell me that, well, it doesn't matter how many pores the material has as long as it's, you know, 98, 99% dense. Whereas if you did a fatigue screening on the material, you might think otherwise. Doing a multi-property sweep on multi-materials sounds pretty daunting for the funding available, but that's for I think the proposal team to evaluate, and you know, I won't say that we'd rule it out as a consideration, but you know, we are certainly seeking authoritative data here and confidence in the results. So.
Next up, it's kind of reiterating a question, but we'll figure out if we come up with a solid answer. Is there a minimum wall thickness feature size within scope? So do we want, is there a starting point that we want them to, you know, not go beyond?
You know, I wouldn't say that there is a lower limit if they're confident in being able to fabricate a useful, reproducible feature out of it. But in our experience, you know, once you go below 10 mil, you're you know, in danger of material integrity issues. So if it's you know, if it's meant solely as a heat exchanging fin, maybe you can live with that. But you know, it won't likely hold pressure once you get too far below that. So I mean, I think 10 mil is an acceptable lower bound.
And to your point earlier, this is not a project that is focused on how do we develop or mature the process such that we can achieve, you know, the lowest or thinnest wall for a particular application. It is really about trying to get that, you know, pedigreed data on thicknesses that are useful today. Next up is, what range of thin wall thickness and narrow passage diameter are you interested in? So I think we kind of just talked through, you know, call 10 mil lower limit. Is there a narrow passage diameter?
So I mean, you know, it's slightly above that range has been our experience, but again, you might propose whatever your experience with that process is. I would say that, you know, 15 to 20 mil is certainly achievable with some difficulty, perhaps, but you know, it's easier to make walls than passages.
Next up, a couple more are here. Is there interest in process parameter manipulation to mitigate the debit? If it can be done, within budget and time?
It sounds fairly risky. I think what we're really seeking is more utilization of current established parameter sets, and then really trying to examine, again, the debits for thin walls and features of that nature with those sets. If the approach was to baseline some optimization against that, that might be acceptable, but again, the real focus is on with the current parameter sets, what are we witnessing? And I think that it's a bit more of a technical risk to really approach an optimization methodology.
All right, I asked that one out of order. There was one that was before that, so I'll go back to that. Who is the end customer or user for the design curves that will be generated? So the design curve debits, or kind of property debits that were coming out of, who do we expect to use these in the end?
Well, this is America Makes is a Department of Defense sponsored institute, so generally speaking, the Department of Defense. I'm not going to go into any further detail than that. I don't think it's really necessary. I think you have the sense of the types of features, and I think any America Makes member that could benefit from the information is also potentially a customer. So I think that the range of applications it's pretty diverse. But again, we talked about some potential uses for these types of activities, including lightweighting of structures, of heat exchangers, pressure containment, fluid flow. This is really not focused on end-use geometries. It's focused on component features of potentially end-use geometries and how we understand the behavior of those features relative to sort of bulk coupons.
Perfect. Next up is, what rules apply to solid metal block support interfaces? As built implies broken off support with stubble left behind.
No, I don't think that's necessarily the case. I mean, all we're implying with as built is that it doesn't receive extensive surface finish improvements. So I mean, if you were to excise specimens for some testing, that's certainly not going to be as built, but it might have as built surfaces exposed in the test. So I think we're trying to avoid methodologies that are not currently employed and would not be feasible for some of the features in question. I might be able. Go ahead.
No, the next one's easy. So if you had any more, go ahead.
No, go ahead.
Next up is just a simple, will webinar be recorded and made available? Yes, the entire webinar is being recorded. I believe if you signed up for the webinar, you'll get sent a link with the recording. I think is how it works. So Aaron, you can correct me if I'm misleading anyone. But that's the last question that I see, Aaron. So
we have two more. So the answer to the recorded, it will be out under the AAPT Project Call website as well as the slides. And then we had another question come in, and it says, who can be lead organization? Who can be the lead organization? An America Makes member has to be the lead organization for proposal teams. That includes whether it be a university, industry, they have to be an America Makes member.
Aaron, do they have to be an America Makes member to propose or to be awarded?
to be awarded, to lead the team. So to propose, to do the concept paper, and once a team is selected for a concept paper, I believe the date is the 28th of September. The team has to be a America Makes member. So prior to the award, so in order to be awarded, they have to be an America Makes member.
Okay, so to be clear, you can lead the proposal if you're not currently an America Makes member, but you would have to become an America Makes member to accept an award if selected.
That's correct. And then we have one more question. Are you interested in varying material properties to decrease surface roughness as an as-built surfaces?
Could you repeat the question?
Are you interested in varying material properties to decrease surface roughness of as-built surfaces?
Not extensively, no. I mean, I think the reality is that we're going to witness rough surfaces with this process, or relatively rough surfaces. I think everyone on the call probably realizes that, you know, upward-facing surfaces are typically more smooth than downward-facing ones. Maybe the sidewall is different depending on the machine and the vendor and the parameters that's used. But by and large, the surfaces can be rough. And so, you know, I think assessing what the realistic and common range of surfaces that are encountered with this process are important. And, you know, again, if some small portion of the proposal wanted to explore looking at improved surfaces and using that as a baseline, then perhaps that would be a worthwhile endeavor. But the essence of the project is we would have to deal with the surfaces we know that we're going to encounter in a large swath of the industry. I also want to emphasize that you know, again, the hip versus no hip is also a particularly important aspect of this program. We've emphasized a lot of the surface finish, and you know, the real challenge would be in combining those two. So either of those are acceptable endeavors by themselves, hip versus no hip, and surface finish debits by itself, but a combination of the two would be sort of a grand challenge, understanding, you know, how those would interplay.
Thanks, Mark. All right, so those...
Hey, one more just came in that I can see on my side. Should narrow passages be opened or closed on top?
Both. I mean, you know, I think that you encounter both in a variety of features. I think primarily the enclosed ones are the most economically impactful. But, I mean, I have seen a case for, you know, open ones. Again, I guess it depends, you know, what exact geometry you're considering there. I mean, you know, you have to be able to have access to the passage. So I hope that's not what's being contemplated, not enclosed volumes with no egress point for powder. That's of little to no interest. But you know, typically I think it's channels through which fluid would flow would be of interest, fluid or gas, I suppose. And I guess those could also be open to the top surface, if that's what's being contemplated there.
But completely enclosed passages, you know, with, I guess, with no egress, meaning left to be filled with powder that's not consolidated, that's of no interest as part of this.
Correct, no interest.
Okay. That's the last one on that I see, Aaron.
All right. Thank you, Mark and John. So all of the questions will be posted to the American Makes website under the AAPT Project All website on Friday. So if you had some that were not addressed somehow, they will be posted. Look for them Friday afternoon, and we look forward to everyone's concept paper submissions. Thank you.
Thanks, everyone. Bye.